All right. Good morning, everybody. Happy Monday. All right, we're going to keep going today with our separation of variables, which is note 78. The differential equations, you're going to need that today. You are also going to need the assignment page. So I'm assuming you've had a chance to download those or else come up and pick one up. And we're going to roll from here. By the way, I was going to send the quiz Wednesday. Did not. It went out today. You can work on it tonight, and we'll look at it tomorrow. So here we go. We left off on this question, example 2, ds dt, root s t, when t is 0, s is 1, find s when t is 9. So if you remember, let's go through our steps again. We separated, we integrated, we used our initial condition to find our constant of integration. So now they're asking us to find the value of s when t equal 9. So here we go. We're going to plug 9 in for t. Of course, s is the variable we're looking for. And there's only one location to do that, and it's right here. So I'm going to take the square root of 9, which of course is 3. 3 cubed, 27, divided by 3, 9 times 2, 18, plus 2 is going to give you 20. Excuse me, just 1 minute. So now we have 2s to the 1/2 is 20. All right, divide by the 2. Nothing magic going on here. And then be careful, don't take the square root. What you want to do is square the left and square the right. And you end up with an s value of 100 when t equal 9. Okay. Everybody good with that? We're waiting to see if anybody types in a question. Good morning. Okay, I'm going on to the back then. Here we go. Problem number 3. Solve the differential equation ln y derivative is y over x when f of 1 is e. Okay, so there's a lot going on here, and I think I'm going to use another piece of paper because this gets a little lengthy and I want to be sure you can see everything. So I've got ln y derivative, y divided by x. So that's what I'm going to focus on first. And remember, here is your dy dx right here. So what I'm going to do then, I've got this ln y, so I've got dy dx ln y is y over x. And I have to separate these variables. I need the y's on the left and the x terms on the right. So I'm going to divide both sides by y and multiply both sides by dy dx. So here we go. We've got ln y divided by y dy is x dx. Take just a minute, look at what's happened, and see how it's going. Now, I've got a little bit of a situation here because when I go to integrate this, I've got ln y over y. And please, 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 you are not canceling these y's out. It is not going to be ln 1. So what I'm going to do, I'm going to call ln y. Absolutely.
Let them know we're going to go offline and we'll be right back.
Okay, we're going to go offline for just a minute and we'll be back.
We're backing up. Just let
Back.
them know the connection is going to be questionable today. We'll do your best.
Okay, so guys, today our connection is a little bit iffy, so we may be in and out, but I'll try and loop back and pick up what we did right before we got lost before. So remember, we were looking at this differential equation, ln y derivative, y over x, and of f of 1 gives me e. So again, I'm rewriting this. I'm changing y derivative to dy dx because they're differential equations and I need that dx in my equation. So it doesn't matter which way you write it, but this serves our purposes here. So I have dy dx ln y is y over x. So again, I need all my y's on the left, and I need all my x terms on the right. So I'm going to divide by y, and I'm going to multiply by dx. And when I do that, I end up with ln y divided by y dy is x dx. Again, don't cross out those y's. You're not going to be able to do that. So resist that temptation. But I do know I can use u sub here. So, so I've got u is ln y, and then du is going to give me what? Of course, 1 over y dy, and there's your magic right there. So let me take this in two different steps. I have ln y over y dy is x dx. I made the u substitution of ln y, so now I have 1 over y times u dy is x dx.
You have a question?
I'm sorry?
There's a question.
Oh, yay. What you got?
Joshua says, isn't it x to the negative 1?
Oh,
X
Josh,
is-
thank you. Yes, he's exactly right. Thank you, Josh.
Question before that too, Dwayne.
Oh, okay, and we have a question before that, sorry. Wouldn't the x be in the denominator?
Yes,
Okay.
y'all are exactly right. Sorry, I got a little fuzzed up when we went offline and came back on. They're exactly right.
Smart kids.
Okay, see if the adjustment I've made here is what we're looking for. Just type yes or no if that's what you're thinking. Are we getting any yeses typed back?
Not yet.
Okay, I'm not going further till someone says yes.
It'll take about 30 seconds to get.
Little delay, yeah.
See how smart they are. Okay, I'm going to assume we got yes there since I'm not hearing from y'all. But thank you guys. Yes, you're exactly right. All right, so du 1 over y dy, I'm going to replace this with du. Everybody with me? So now I've got u du x to the negative 1 dx. Okay? Now we're going to integrate. And we're going to end up with 1/2 u squared. Remember, your constant of integration goes on the x side, not the y side. Is going to be ln x plus c. Everybody good there? All right. It's indefinite. I'm going to have to make my substitution back. So I've got 1/2 ln y squared is ln absolute value of x plus c. Everybody good? Okay, they gave me an initial condition. F of 1 is e. So wherever there's a y, I'm going to plug in my e value, and wherever there's an x, I'm going to plug in my 1. So I have 1/2 ln e squared is ln 1 plus c. Here's my y value. Here's my x value.
Landon Sparrow says, can you repeat that? I got cut out again.
Yes.
Oh, never mind.
Well, I mean, that was a while back, but I didn't know if you wanted to.
Okay, hey Landon, we got a question from you and we're not sure when it came in. So either type that you're good or that you need me to repeat something. And we're going to pause for just a second while that message gets to him.
maybe keep talking a little bit.
Okay.
Maybe explain just the very last thing.
Okay, I'm not sure where we're backing up, so here we go.
Oh, it was when you were asking for a yes from everyone.
Oh,
Oh, okay.
okay.
That was the
So
one.
we should be good then. Thanks. Okay, so here we go. ln e to what power is e? Of course, that's going to be 1. So I have 1/2 times 1. E to what power is 1? Any number to the 0 power is 1 plus c. So my constant of integration in this case is 1/2. So the entire equation, well, actually, I think we're going to stop at this point on this question and move on to the next piece. All right, let me just review this real quick. Here we go. We were given ln y, y derivative, y over x. I changed my y derivative to dy dx. That introduces the dx into the equation. I separated. So I've got ln y divided by y dy is x to the negative 1 dx. I'm going to use u substitution for ln y. du gives me 1 over y dy. So I've got 1 over y u dy. I'm replacing the 1 over y dy with du. I have x to the negative 1 dx. My antiderivatives, 1/2 u squared ln absolute value of x plus c. I have to plug back in for my u sub. There's my ln y. And now I'm going to use the condition f of 1 is e. So where there's a y, I'm putting in e. Where there's an x, I'm putting in 1. Now, I'm also dropping the absolute value bar because 1 is 1. It is a positive number. I don't need absolute value at this point. ln e is 1. ln 1 is 0. c equal 1/2. All right. Let's move on to example 4. All right. At each point, x, y, on a certain curve, the slope of the curve is 3/4 y. So they're giving you your dy dx right there. They're telling you the slope of the curve, the derivative, is 3/4 y. And again, sometimes you have to know what you're reading. The slope of the curve, the derivative of the curve at that point, dy dx is 3/4 y. The curve contains the point 0, 10. Find its equation. So again, they're giving you this initial condition. All right, so let's just start working over here. I have dy dx is 3/4 y. This is a constant, the 3/4, that I'm going to leave on the right-hand side. I need to move the dx to the right and the y to the left. So I'm going to divide by y. So I have 1 over y dy is 3/4 dx. Okay, everybody good there? All right, there's our separation. Now we're going to do our integration. So I'm integrating y to the negative 1 dy, and I'm integrating 3/4 dx. All right, well, the antiderivative of 1 over y is ln y. And the antiderivative of 3/4 is going to be 3/4. Remember, it's just a constant, x, and then we add our constant of integration to this side of the equation. So we have ln absolute value y is 3/4 x plus c. Everybody good there? Okay, now we're ready to use our initial condition. Let me come back up here with my equation. So I've got ln y 3/4 x plus c, and they've told me 0, 10 is on the curve. So I've got ln absolute value 10 is 3/4 0 plus c. Clearly, the constant is ln 10. Now, I left this step out of the last equation, but we're going to go in and do this now. Or I left it out of example 3. We're going to jump in now on example 4 and do this. So I'm going back to the equation that we came up with here, where we had c as being our unknown. Well, now we know the value of c. So now I've got ln y is 3/4 x plus ln 10. Okay, this is important. We haven't isolated y yet. We've isolated ln y, but not the y value. And until that y value is by itself, we don't have an equation. So here's what's important. Remember, we have the unwritten e here. So I've got e to all of this is my y value. So I've got e to the 3/4 x plus ln 10 is y. Remember, if we work backwards, if I have x to the 4th times x to the 3rd, we have x to the 7th. And what did we do? We did x to the 4 plus 3. So you have your e equation here written in this format, and we're going to back it up and separate it. So I've got e to the 3/4 x times e to the ln 10 is y. Well, this is important because now, remember, base log base x is x. You've got base log base. So this piece of our equation right here turns into 10. So now I've got 10 e to the 3/4 x is y. And that separation of that exponent is going to be really important to us. We're going to see this as c e to the kt power. Take a minute and let that sink in, and if you have a question, go from there. Good? Okay, again, this is a huge concept, and you're probably going to want to rework this problem a couple of times because we're heading to, the other way we saw this last year was you saw PERT, remember? Which was principal, rate, and time. Well, now you're seeing the constant and some time value and some constant. So nothing's really changed here. We're just using different variables on it. Okay, let's move on. Example 5, find the general solution. So all we're doing here is just a family of functions. We're just looking for the general solution to the differential equation dy dx is y minus 2 sine x. Now remember, you cannot add and subtract to separate in differential equations. So we have dy dx is y minus 2 times sine x. So when I separate now, the y minus 2 is what we're going to divide both sides by. So I've got dy, over y minus 2 is sine x dx. You can't separate the y minus 2. That's a big concept right here. Okay. Well, 1 over y to the stuff, the antiderivative of that is ln the stuff. So we've got ln y minus 2. And my antiderivative of sine is going to be negative cosine x. And there's my constant of integration. So the main reason we're looking at that is just to know you can't divide by the y and add the 2. You've got to keep the number together. All right, so now they're taking us to the next part. Find the particular solution of part A if f of pi over 2 is 8. So, and in the interest of space here, well, I can probably fit all this in. So they're giving me an x value and they're giving me a y value. So I'm going to plug that in where I can. I've got ln 8 minus 2 is negative cosine pi over 2 plus c. Well, 8 minus 2, of course, is 6, and 6 is positive, so I can drop the absolute value. And cosine pi over 2 is 0. So the c value here is ln 6. All right, so here we go, back up into the equation. And we've got ln y minus 2 negative cosine x plus ln 6. Again, think about reading this in a circle. E to the negative cosine x plus ln 6 is y minus 2. And that's going to drop the natural log from the left-hand side of the equation. E to all of this is that. You should already be seeing you're going to have e to the ln 6, which is going to be a constant of 6. There's your c in the equation, but let's just, hang on a second, let me get a piece of paper. All right, here we go. So we have e to the negative cosine x plus ln 6 is y minus 2. Okay, again, working backwards, remember you really have e to the negative cosine x times e to the ln 6. Base log base x is x. This is 6. So I've got 6e to the negative cosine x is y minus 2. And again, that goes in to ce to the kt. We're going to be seeing that in our growth functions and our decay functions. And once you got your mind wrapped around that, it's really not that difficult. All right, I'm going to add 2 to both sides. And I'm going to get y equals 6e to the negative cosine x plus 2. And that's our particular equation from example 5. Which, of course, we'll use to solve other equations later. And then it says, notice the examples, here we go. So when I have dy dx, some constant times y, we're going to end up with this situation. Because you're going to end up with e to whatever. Let me just use the negative cosine x. And then you're going to have e ln some constant right here. I should have written that with a c, I'm sorry. And that constant is going to go to the front because you have base log base x is x. All right, that is a lot of information. Let's go on to the assignment. Separation of variables worksheet. Okay, we've got, 16, 17 minutes, something like that. So let's just start working them together. We'll work the odds, and you're going to work the evens. Let's get through the odds first, and then if we still have time, we can go through the evens. If we don't, when you tune in tomorrow, we'll see how we did. All right, problem number 1. dy dx is xy squared, and f of 1 is 1. So I've got a differential equation. I've got an initial condition. I'm going to find the function. So the first thing I'm going to do is separate. So I have dy over y squared is x dx. Again, point. Point for separating your variables. Now we're going to integrate. It's not 1 over y, it's 1 over y squared. So you're really integrating y to the negative 2 dy and x dx. So we're going to add 1 to it. Remember, we're working towards the function, not towards the derivative. So I have y to the negative 2 plus 1, which is going to be y to the negative 1, divided by negative 2 plus 1, negative 1. So we end up with an equation of negative 1 over y is 1/2 x squared plus c. All right? We've separated, we've integrated, we've added our constant of integration, and now we're going to use our initial condition. F of 1 is 1. Wherever there's a y, I'm going to plug in 1. Wherever there's an x, I'm going to plug in 1. So I have negative 1 over 1 is 1/2 1 squared plus c. So I'm getting negative 3/2 for c. So let's go back into the equation. So we've got a little bit out of room, but that's all right. I'll just come up here and keep running. Okay. We have negative 1 over y is 1/2 x squared minus 3/2. We have to solve for y. Y is not by itself at this point. So I think the first thing I'm going to do is multiply by 2. And that gets my denominators gone. I'm going to multiply both sides by y and divide by both sides by x squared minus 3. And there's our equation for y. Let's review our steps. We have separated. We have integrated. We've added a constant of integration. We've used an initial condition. And we've solved for y. So right there, again, if this is a free response question out of 9 points, you've probably got an easy 4 or 5 right there. Now, if the wheels fall off after that, there'll be more to the question than that. That's okay. You still done very well. So don't let these intimidate you. All right. Let me just give you the answer for number 2. The answer is going to be y equals square root x squared plus 7. If we have time, we'll come back and work it. All right. Let's look at problem 3. Find f of x by solving the separable differential equation. dy dx is 3x squared plus 1 over 2y. Initial condition, f of 1 equals 4. I need a little more paper, so I'm going to add to this. Okay, we're going to multiply both sides by 2y, and we're going to multiply both sides by dx. That'll separate our variables. So I've got 2y. dy is 3x squared plus 1 dx. See if you agree. We're going to integrate. Constant of integration only goes on the x side of the equation, not on the y side. Y squared. That seems too easy, but whatever. X cubed plus x plus c, 3x squared. Okay, yeah, that just seemed a little easy. There you go. Our initial condition, we've separated, we've integrated, we've added our constant of integration. Our initial condition, f of 1 is 4. So 4 squared is 1 cubed plus 1 plus c. See if we agree. Okay, so at this point we know that y squared is x cubed plus plus 14. The problem is we don't have y by itself. So we don't have a function here, so we're going to take the square root of both sides. Great. Square root of 25 is 5, and it is also negative 5. Don't forget, you have a positive and a negative side of this equation. So how do you know which situation you have? Are you talking about the positive or the negative side? Well, if we go back to our initial condition, because remember, your y squared is going to graph like this. So am I looking for this arm or this arm? If I go back to my initial condition, f of 1 gives me 4. That's the positive side of the equation. So the only answer that's going to work here is that y equals the positive root of x cubed plus x plus 14. Okay? All right, let me give you the answer to 4, because how much time do we?
Just a second.
Yes, we're going to pause for just a second. You're not happy. Hmm?
We're back online, but it's mainly audio. Hang on just for a minute. It'll kick back up.
Mm-hmm.
Just let them know the video is offline for just a second. They can hear you right now,
Oh, okay.
but they can't see much right now. So just let them.
Okay, so what I'm hearing right now is that our video is offline, but the audio is still online. You should still be able to hear me, but you probably won't be able to see what's on the board.
Okay, I think you're back up.
Okay. Looks like we're back up. The answer to 4 is going to be y equal 4 e to the 2x squared power. I don't know why I decided to cram that in at the very top of that. Sorry. All right, let's look at problem 5. All right, first of all, you can see you're going to have dy dx 2xy, so you're going to be dividing by y, which means you're going to have natural log introduced into this problem. Everybody see that? I know I said that really fast. When I separate these variables, I'm going to have dy divided by y is 2x dx. 1 over the stuff. The antiderivative is ln the stuff. So here we go. Integrate, and we're going to have ln y is x squared plus a constant of integration. Okay, they've given me this condition here. Y is 2 when x is 0. So I think it's fairly easy to see that c is ln 2. And again, that's going to give you e to the x squared plus ln 2, and there's your c in the equation, the c equal kt. But I'm getting a little ahead of myself, but here we go. So now we're going to plug that in, and we've got, excuse me, ln y is x squared plus ln 2. Y is 2 when x is 0, so we're working on the positive. I'm going to drop the absolute value bars. So here, remember, e to all of this is y. So e to the x squared plus ln 2 is y. And here is your c in the formula. When you separate it, e to the x squared times e to the ln 2, this is 2. So I've got y equal 2e to the x squared. You with me? All right, so let's take this, let me see what I want to do here. Then they're telling me when y equal e, x equal whatever. So here we go. When y is e, x is our unknown. So what I'm going to do is use this equation right here. I'm solving for x now, not for y. So I know that y equal e, is 2e to the x squared. Everybody with me? We could use it with this equation, or I'm just trying to think which equation would have been a little bit easier. Hang on just one second. Let me see which direction I want to take with this. All right, let's just keep going on the path we're going. I'm solving for x, so I'm going to isolate it. So I'm going to switch this up. I've got e to the x squared is e divided by 2. With me? I'm going to take the natural log of both sides. So I have x squared ln e is ln e over 2. Of course, ln e is going 1. So x squared is ln, I don't know if y'all have your calculators with you or not. Ln e over 2, and you'll take the square root of both sides. Or you can evaluate ln e over 2, so hang on just a second. So we have a value of 0.553 for our x. The big part of this problem, I'm less concerned about the answer. I'm more concerned about all the work up in here and getting this y is 2e to the x squared value there. I keep shifting gears here because there's another path we could have taken, but I like this path better. So I'm going to leave. Okay, problem 6. We are almost out of time, so let me just give you the answer. Problem 6 is y equal 3e to the sine x. And let's jump down to 7. At each point x, y on a certain curve, the slope of the curve is, again, here you go. This is your dy dx right there. And then they're not telling you that. They're not saying here's dy dx, but they're telling you that. So I would write that down as soon as you figure that out. Dy dx is 2y over x. Here's another x to the negative 1. Maybe I won't forget it this time. I'm going to leave the 2 with the x and move the y to the other side. So I'll have dy divided by y is over x dx. Sorry. Okay. We're going to have logs on both sides. When we integrate, I have 1 over y and 1 over x. The 2 is just our constant of integration. So my antiderivative, ln y, 2 ln x plus c. Okay. Now at this point, you have e to all of this, right? And here's your constant of integration. This is the c that we've been talking about earlier. So keep that in mind. You're going to have one other thing we want to look at. Remember, if I'm using logs, that 2 turns out to be an exponent. So I've got e to the ln x squared plus c is going to be the y value there. This is my constant of integration, ce to the kt. So I have ce ln x squared is 1. And again, you've presented yourself this situation twice because e base e x squared. So it's repeated. So I have c x squared is y. That one is a little slippery, and if you don't understand that yet, don't worry too much about that. We'll talk about that problem a little more as we move on. All right, last but not least, the answer to number 8 is going to be y equal e x to the 1/2 minus 2. All right, so you have quite a bit on your plate tonight, which is to finish all the odds here. Also, the quiz I sent with you. I know this stuff is a little, at first. I'll post the notes and the assignment that we did today online so you can follow back if you need to. Tomorrow, I'll answer all your questions about this. I know it gets a little strange at first, but remember, you're just learning it. Also, you can text me on Remind if you have questions about any of the problems, and we'll go through them. A brand new concept. Please don't stress out about it. We have 2 more lessons. Hang on one second. I'm sorry. We have 1 more lesson, then the review, then the test. And I think I'm going to be talking to Mr. Gonzalez this week, but I think we're going to set up a system where you can come in and take the practice exams over the next couple of weeks. All right, you guys, thank you so much. See you tomorrow.